In this video, you're going to learn how to expand a binomial raised to a power by using the binomial theorem. We're also going to talk about how to use Pascal's triangle, as well as if you just want to zero in and find a particular term in a binomial expansion, or even just find the coefficient. So we're going to go through 6 problems. I'll have some that you can practice on your own. We'll go through all of these together, and I'll show you some tricks and techniques as we go through this just to pay attention to. So let's start off with this first one. If we want to expand 2x minus 3y to the third power, one way we could do this is we could just think of 2x minus 3y multiplied 3 times. So we have 3 of this group. We'd have to FOIL 2 of these together, multiply them together, and then multiply by this last binomial, and then simplify. So that's one way to do it. But the binomial theorem is designed to make this a lot quicker, especially when you raise this to like a higher power, like 4 or 5 or 6, etc. So what we're going to do is we're going to talk about Pascal's triangle. And Pascal's triangle, basically, it starts with 1, and each row starts with 1 and ends with 1. Okay, you can see that. And then what we're doing is you're adding the terms above it to get the term below it. So 1 plus 1 is 2, or 1 plus 2 is 3, or etc. And you keep working your way down. But where these numbers can also be derived from is from the combinations. So when you learn about permutations and combinations, remember the NCR. Out of n items, how many ways are there to choose R of those items where the order doesn't matter? And we use this formula n factorial over n minus r factorial. So what you could do, let's say for example, if you're down here at this row, okay, which this is called the 4th row, it starts at row 0, then it goes 1, 2, 3, 4. You can tell what row you're on if you just look at that second number. See, this is the 4th row or the 3rd row. That's the one way to kind of help as you go further down. But this 1 here really comes from 4C0. Out of 4 items, how many ways are there to choose 0 where the order doesn't matter? Well, there's only one way of choosing 0 items out of 4, right? And then this one, out of 4 items, how many ways are there to choose 1 item where the order doesn't matter? That's 4. And out of 4 items, how many ways are there to choose 2 where the order doesn't matter? That's 6 ways, etc. But what we're going to do is we're going to use these coefficients to help us in this expansion here. So we can do this a couple different ways. One way to do it is to start with, this was to the 3rd power, so we're going to start with row 3 here. And these are going to be our coefficients, 1, 3, 3, and 1. Now remember where these come from. This is really the same thing as 3C0, 3C1, 3C2, and 3C3. Then what we do is we take this first term, 2x. You want to take that whole group here, and you're going to raise it to the 3rd power. And then you're going to go in descending order. So 2x to the 2nd, 2x to the 1st, 2x to the 0 power. Then you take the second term, and you want to make sure you capture that minus sign, that negative sign. This is going to be negative 3y to the 0th power. And then we're going to go in ascending order, so we're going to go up. So negative 3y to the 1st, negative 3y to the 2nd, negative 3y to the 3rd. Now I want to show you some patterns here that are important to recognize. Notice how this r value, 0, matches the second term's power here, 0. See 1, 1, 2, 2, 3, 3. That's important. We're going to use that a little bit later in this video. The other thing that's important to remember is see these two exponents. 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Now what we're going to do is all these terms are going to be added together. So just think of a plus sign between all of these terms. Let's go ahead and simplify. So we have 3C0, which is 1, times 2x to the 3rd power. So this is coming out to 1. 2 cubed is 8, so this is 8x cubed. And anything to the 0 power is 1. Okay, so if we simplify that, this comes out to just 8x to the 3rd power. Okay, the next term, we have 3c1, which is 3. We have 2 squared, which is 4, x squared. Negative 3y to the 1st, of course anything to the 1st is itself. And so now if we simplify this, we get let's see, negative 9 times 4 is negative 36, x squared y. Okay, and then for this next term, we've got 3c2, which is 3. And we have 2x to the 1st, anything to the 1st power is itself. Negative 3 squared is 9 y squared. Okay, so if we simplify that, we get 6 times 9 is 54 xy squared. And then the last one, 3c3 is 1, and anything to the 0 here is 1. And then negative 3 cubed is negative 27, y to the third power. So if we multiply all that together, we just get negative 27y cubed. So all these terms are going to be added together, so our final result is going to be 8x to the third minus 36x squared y plus 54xy squared minus 27y cubed. And you've expanded it, and that's it. Now, one thing to pay attention to is, see how this is subtracting? When you're subtracting like this, notice these terms alternate, positive, negative, positive, negative. If they were both positive, these would all be positive, all these terms. And the other thing to watch out for here is that you can use the combinations like I was showing you, okay? Or you can just use Pascal's triangle. Just go down here to row number 3. Again, remember this starts at row 0. Let's talk about another example where you're just zeroing in on a particular term, not doing the whole expansion. Let's look at that next. So how do we find the third term in the expansion of 5x plus 7y to the 7th power without having to actually expand the whole binomial using that binomial theorem? Well, what we can do is we can use that pattern we were talking about earlier in the first question. We could say, well, if I want to go down to the 7th row in Pascal's triangle, right? It would start off with 1, and then 7, and then etc., right? But where are those numbers coming from? It would start off with 7 choose 0, 7 choose 1, 7 choose 2, etc. So the third term here is actually going to be 7c2. Why 2? Because we're starting each row with 0. So this is going to be 7c0, 7c1, 7c2. That's actually our third term. And then look at this pattern here. We've got our two terms, 5x and 7y. But remember how we said that this r value here and the exponent on the second term, they're always in lockstep, they always match. And remember the pattern where we said these two exponents here are going to add up to this power here, the 7. So in this case, this has to be to the 5th power. So now we've zeroed in on that particular term. All we have to do is simplify. So 7c2, you could do this on your calculator if you have a combination key on your calculator, or you can use the factorials, this formula here. So I'll show you, if you expand this, this will come out to 7 factorial over n minus r, so that's going to be 7 minus 2, which is 5 factorial, and then r factorial, which is going to be 2 factorial. Okay, then we're going to say, well, 5 to the 5th, which is 3,125, x to the 5th, 7 squared, that's 49, y squared. Okay, so continuing to simplify down here now, 7 factorial represents 7 times 6 times 5 times 4 times 3 times 2 times 1. Remember, the factorial tells you start at this number, you multiply down to 1. Same thing with 5 factorial, that's 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. So notice the 5, 4, 3, 2, and 1 cancel numerator and denominator. 7 times 6 is 42, 2 times 1 is 2, 42 divided by 2 is 21. So we have 21 times this whole quantity, 3,125 x to the 5th times 49 y to the 2nd. Let's go to the calculator and finish simplifying that. That's 21 times 3,125 times 49. This is coming out to a large number here. This is coming out to 3215625 x to the 5th, y to the 2nd, and you've zeroed in that particular term. Now let's talk about a problem that involves just solving for this coefficient in front of the variables. Let's do that in example 3. Find the coefficient of the x cubed y squared term in the expansion of x minus 2y to the 5th power. So how do we do that? Well, what I like to do is I like to write down my two terms. This is my first term, x. This is my second term, negative 2y. And I know the exponents here because I know I want to end up with x cubed y squared. So this has to be to the third power, this has to be to the second power. But we're on the fifth row of Pascal's triangle, right? So this is to the fifth power. So this is going to be 5c, and remember the connection here between this second term's exponent and this r value? So this has to be 5c2. So now we've zeroed in on the term, but we want to find out just the coefficient, the number that comes in front of this x cubed y squared. So let's simplify a little bit more. So 5c2, using our combination formula, is going to be 5 factorial over 5 minus 2, 3 factorial, times 2 factorial. This is going to come out to x cubed, and negative 2 squared is going to come out to 4y squared. A negative times a negative is a positive 4. Now if we simplify here, 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. So you can see the 2, the 1 are canceling numerator and denominator. These 3's are canceling. This comes out to 20. This comes out to 2. 20 divided by 2 is 10. So we have 10 times 4, which is 40 x cubed y squared. We just want the coefficient, so we're just after this number that comes in front here, so your final answer would be 40. Okay, for example number 4, 5, and 6, they're going to basically be repeats of example 1, 2, and 3. So see if you can do these problems on your own. We'll go through them together. And let's dive into number 4 now. It says expand 4x plus y to the fifth power. Well, if I was going to do this, I would use either the combinations or I would go down to the fifth row in Pascal's triangle. So here previously I went down just to the fourth row. So remember, each row starts with 1. Then I add the two numbers above it. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10 again, 4 plus 1 is 5, and 1. Remember, it always begins with 1 and ends with 1. One thing you'll also notice is it's symmetric. See, 1, 5, 10, right? Okay, so we're going to use those coefficients, 1, 5, 10, 10, 5, and 1. Remember where they come from. They really come from the 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. Then we take our first term here, which is 4x, and we take that to the fifth power, and we go in descending orders. So 4x to the fourth, 4x to the third, 4x to the second power, 4x to the first power, and 4x to the 0th power. Then we take the second term, which is positive y, or we could just say y. We start at the 0th power, and we go in ascending order, meaning we're going up. So y squared, y to the third, y to the fourth, y to the fifth. And notice these are all multiplied together, and then each individual term is added to the next term. So there's like a plus sign in between each of these terms. So now let's go ahead and simplify this down a little bit. And so what do we get? It looks like we're getting 5c0, which is 1. 4 to the fifth power, I have to go to the calculator on that one. It's 1024. X to the fifth. And then y to the 0, anything to the 0 power is 1. So 1 times 1 is 1. So this is just coming out to 1024 x to the fifth. That's our first term in this expansion. Second term, we've got 5c1, which is 5. And then we've got 4 to the fourth power, which is 256. X to the fourth, y to the first. Okay, so if we multiply that together, that comes out to 1,280 x to the fourth y. 5c2, that's 10. So we have 10. 4 cubed is 64, x cubed, and y squared. So if we multiply that together, we get 640 x cubed y squared. And then for the next term, 5c3 is 10. So we have 10. 4 squared is 16, x squared, y cubed. So if we multiply that together, you can see we're getting 160 x squared, y cubed. This term, 5c4, is 5. So we have 5 times 4x to the first is 4x, y to the fourth. And if we multiply that together, we're getting 20x y to the fourth. And the last one, 5c5 is 1, 4x to the 0 is 1, y to the fifth. So that just simplifies to y to the fifth. And then all these terms are added together. Now you can write it horizontally. I have it here vertically. Normally we write it horizontally. But again, notice some of the patterns here. See how this first term we had 5c0, and this r value is matching with this second term's power. We also notice that 5 plus 0 is 5. Or if I jump down here, see how this is like r value is 3 and the second term's power is 3. They match. 2 plus 3 is 5. See that exponent, that power. So we're going to use that in the next problem where we zero in on just a particular term without having to do the entire binomial expansion. Find the fifth term in the expansion of 2x minus 7y to the 8th power. So we don't want to take the time to do the entire expansion. We just want to zero in on this fifth term. But notice this is to the 8th power. So what we could do is we could go down to the 8th row of Pascal's triangle, keep expanding. That would take a little bit of time though. The other way to do it is we could use the combinations to help us to write that 8th row. And if we want the fifth term, knowing that this always starts with 0, that's going to be 8c0, 8c1, 8c2, 8c3, 8c4 is actually going to be for our fifth term. Notice it's one less because we're starting at 0 right here. So this is going to be 8. That's coming from this power. Okay, that's the row we go to. C4, one less than the fifth term because we're starting at 0. Then we're going to take our first term, which is 2x, our second term, which is negative 7y. And remember the pattern here. This r value and the second term's exponent, they match. They're the same. These two exponents have to add up to this power here, 8. So that means that this has to be to the fourth power because 4 plus 4 is 8. So now we've zeroed on that particular term. Let's just go ahead and simplify. So 8c4, using our combinations formula here, is going to be 8 factorial over 8 minus 4, 4 factorial, 4 factorial. Okay, 2 to the fourth we know is 16, x to the fourth, and negative 7 to the fourth. Let's do that on the calculator. That's coming out to 2,401. Positive, because a negative times a negative times a negative times a negative, an even number of times is positive. And so now let's simplify this. So 8 factorial is really 8 multiplied all the way down to 1. 4 factorial is 4 times 3 times 2 times 1. And this 4 factorial, 4 times 3 times 2 times 1. You can see these are canceling, numerator and denominator. Let's see, 4 times 2 is 8. That cancels with this 8. 3 times 1 is 3. That goes into 6 twice. 2 times 5 is 10, times 7 is 70. So what we have is 70 times all of this. So let's go do that on the calculator. 70 times 16 times 2,401 is giving us 2689120, x to the fourth, y to the fourth. And that's just that particular term, the fifth term in this binomial expansion. Okay, before we jump into this next problem, which I'm going to actually have another problem after this as well, a bonus problem. So we'll actually have 7 problems in this video. And congratulations for sticking with me this far. You must be pretty dedicated. I just wanted to let you know, if you like the way that I'm explaining things and you would like to learn more about either Algebra 1 or Algebra 2, College Algebra, I have video courses for sale with links in the description below. So check out those video courses if you want to learn more about Algebra 1, Algebra 2, College Algebra. And if you just want to support the channel, consider joining as a channel member. For a few dollars a month, you can help support the content that I'm putting up here for you guys, and I'd really appreciate it. So thank you for that. But let's jump into number 6. So can you do this problem? Can you find the coefficient, meaning the number that comes in front of this variable expression, x to the fifth, y to the second, in the expansion of 3x minus 5y to the seventh? How would you do that one? Well, go ahead and pause the video, see if you can do it. And in the meantime, what I would do is I would either go down to the 7th row in Pascal's triangle, if I had that written out, or I can use the pattern of the combination. So it would start off with 7c0, 7c1, etc., right? And I know that I'm dealing with these two terms here, which are 3x and negative 5y, okay? And I know that these exponents have to be 5, because I want to end up with x to the 5th, and this has to be 2. And this makes sense because 5 plus 2 adds up to this exponent here, 7. And again, we're on the 7th row. And remember the pattern where this second term's exponent is the same as this r value right here. So that's a match. So now all we have to do is just simplify this. 7c2, you can do this on your calculator, or you can use the formula, the NCR formula. That would be 7 factorial over 7 minus 2, 5 factorial, 2 factorial. 3 to the 5th is 243, x to the 5th, and negative 5 squared is 25, y squared. If we simplify this, 7 factorial is 7 times 6 all the way down to 1. 5 factorial is 5 all the way down to 1 multiplied together, and 2 factorial is 2 times 1. So you can see the 5, 4, 3, 2, 1 cancel numerator and denominator. 42 divided by 2 is 21. So this would be 21 times these other terms. So this is going to be 21 times 243 times 25, which comes out to 127,575 x to the 5th y squared, but we just want the coefficient. That's the number that comes in front of x to the 5th y squared, so just the 127,575. Let's go ahead and take a look at a bonus question here involving imaginary numbers. This is a little bit more challenging. See if you can do this last problem. 2 plus I to the 4th power. How would you expand that? And the I represents the imaginary I, where it's equals the square root of negative 1. So how would you expand that and simplify it? Write it as a complex number in standard form, a plus bi form. So this is kind of a little bit more challenging, but it's the same idea. You have a binomial, two terms. We're on the 4th row, right? So this would be 1, 4, 6, 4, and 1. Those are our coefficients, so let's write that down. And then we have 2, our first term, to the 4th power, 2 to the 3rd, 2 to the 2nd. We're going in descending order, 2 to the 1st, and 2 to the 0. We take our second term, which is I, and we go to the 0th power, and we go in ascending order. We go up. And then all we have to do here is simplify. So 2 to the 4th we know is 2 times 2 times 2 times 2, that's 16, times 1 is 16, anything to the 0 is 1, so this comes out to 16. 2 cubed is 2 times 2 times 2, that's 8, times 4 is 32, times I, so that's I. 2 squared is 4, times 6 is 24, I squared. Okay, now I squared is how much? Well, I squared is equal to negative 1. So it's I times I, which is I squared, that's negative 1. So this would really be equal to negative 24, because negative 1 times 24. And then I cubed is equal to I squared times I to the 1st. I squared we know is negative 1 times I is negative I. So this would be 2 times 4 is 8 times negative I, which would be negative 8I. And then over here, I to the 4th is equal to I squared times I squared. I squared is negative 1 times negative 1, which is positive 1. So this is 2 to the 0 is 1, I to the 4th is 1, times 1 is 1. Now what we want to do is we want to combine like terms. So we have 16 plus negative 24 is negative 8, plus 1 is negative 7. And we've got negative 8i plus 32i, which is 24i. And you can see it's in that standard form of a complex number where you put the real number first and the imaginary second, the a plus bi form. And that's your final answer. So great job. Let me know if you're able to get that one in the comments below. And if you want more practice, more examples, follow me over to that video right there where I talk more about binomial theorem and expanding binomials. I'll see you in that video.